Teledyne FLIR is the leader in thermal imaging worldwide, and we also are the only supplier in the automotive market today. So thermal imaging is technology that's long-wave infrared, so you hear a lot about infrared on vehicles, but this is the one that's passive, and so you don't have any kind of interference from other sensors that might be out there. Yes, we're showing two items, mainly the ADK, the Automotive Development Kit, which is a hardware product of a thermal camera that is very similar to the thermal cameras on vehicles today. And also we're demonstrating Prism AI, which is our neural network that's associated with thermal imaging. What makes them unique in the market mainly is on the thermal technology is probably the best technology on vehicles today that can detect living creatures. So if you're going with the rules of robotics and you don't want to harm a human, a thermal camera is the best way to do that. So traditionally, the main challenges with thermal technology have been multi-fold. There's the challenge that academically, not a lot of folks have worked with thermal imaging. So having a background myself in LiDAR, LiDARs are in use pretty ubiquitously in universities, whereas thermal cameras, because of traditional export regulations, are not used academically at all for self-driving and ADAS tasks. So that's one of the main challenges, is kind of the younger generations of engineers haven't yet had a chance to work with it. And that's one of the reasons why we have the ADK, to make it easier and more accessible to work with thermal data. Another challenge with thermal cameras has been the cost. Traditionally, it's been a low runner in cars. Maybe 100,000 cameras a year is what we supply. And that's no way to get to scale the kind of cost that you need for an ADAS sensor. And finally, the third challenge has been the cameras traditionally have not been purpose-built for interfacing with ADAS systems. So in other words, they aren't ASIL-rated cameras, and ASIL rating is kind of key for integrating into a control system where you can have absolutely no problems with the reliability of the data. It's been slower to take off than, let's say, visible cameras, mainly because of the cost. And it's not been something that's been used regularly. You know, the difference is with a visible camera, we've had hundreds of millions of cell phones that have been able to scale the technology of visible cameras. We don't have an analog to that in thermal imaging. Traditionally, it's been used by defense industries, space, things that are much lower volumes. And so the ability to scale that to get to lower prices for automakers and for consumers to be able to adopt readily is probably one of the bigger challenges. It is currently in use quite a bit today on cars, but they tend to be higher-end vehicles. We'd like to see it used among all cars so that the safety of pedestrians and safety of the driver in cases of animal interactions is greatly improved.